Praise God. Today we're going to be looking at parallelograms and wedges as we continue our discussion on mensuration. I'm Teacher Walton. And as usual, we're going to God's word in Jeremiah 29:11. It says, "For I know the thoughts that I think toward you, said the Lord, thoughts of peace and not of evil, to give you an expected end." I declare that God's thoughts of peace and the fulfillment of his will for my life will surely come to pass. Amen. So let's go to question number one. Question number one, we are given a parallelogram ABCD whose length AB is 9.8 meters and AD is 11.7 meters. If the size of angle BAD is 36, find its area. And the area of a parallelogram is based by height. So let's get a sketch of this parallelogram here. And we could attempt to put in our information. So remember, with a parallelogram, you have two shorter sides are being parallel, and the two longer sides are also parallel, hence the reason named parallelogram. So AD is the longer side, and AD is equal to 11.7. AB is the shorter side, which is 9.8. And the area of a parallelogram is the perpendicular height. So if we were to drop a line perpendicular forming 90 degrees at this point, let's call this C, A, B, C, D, let's call this point E. Then if we need to find the area of this parallelogram, we need to find what is the length of this height. Now, the interesting thing, we are told that angle BAD is 36 degrees. So we can use, first of all, our sine rule, which says sine 36 is opposite, right? Opposite will be BE, that's the opposite side, divided by the hypotenuse, AB. Right? So we know BE is the unknown. Right? Let's simply call it X. I leave it as BE. Let's call it as BE. And then we divide it by AB, which is 9.8. Now, there's a rule in math that says we can simplify this by cross multiplication. So BE by 1, which is BE, is equal to 9.8 multiplied by sine 36 degrees. So we need to simply work out what is sine 36 and then multiply that answer by 9.8 to get the length of BE. So let's see if we can call up our scientific calculator here. Let's find it. And let's go to trigonometry function. Sine 36 equals, right, so let's put in the 36 first. Sine 36 as 0.587 and so on. Multiply that by 9.8. Right, so that distance would be about 5.76. So this distance here would be 5.76. That's our BE, 5.76, which is approximately 5.8 meters. All right, so there's about 5.8 meters. And we multiply that. Let's see if we can work out our area now. So we just got the height. So the area of this parallelogram based on the formula will be the base the base happens to be AD, which is, and we multiply by the perpendicular height, which we just found to be BE. So the area will be 11.7 multiplied by 5.8. And that'll give us the area for this parallelogram right there. So that area would be 67.86 meters squared. Okay, let's go to question number 2. Where are you? There's question number 2 right there. So we work in wedges and parallelograms. So this is an example of a wedge. Right. And this is taken from modified question. I believe it was June 91, thereabouts, CSEC June 91, some modified question. And we are asked to find the length BD. So let's go to this question. Notice that the triangle, right? Notice this triangle, C being 90 degrees, D and B. This is 6 centimeters. This is 8. And we ask to find BD. So there's a rule which we know as Pythagoras theorem, which says once you're working with a right angle triangle, then the hypotenuse square, which is BD, hypotenuse is the longest side of the triangle, BD square, would be the sum of the square or the squares of the other two sides. So that'll be BC square plus DC square. And we have BC square would be 6 square and DC square would be 8 square. 6 squares 36, 8 squares 64. So that gives us a plump 100 right there, 100. So BD square is 100. So if we need to find BD, we'll take the square root of 100, which will be 10. So we'll write that in right here, 10 centimeters. That's BD. So how do we find the surface area in centimeters square of the wedge? Well, we look at all the different shapes and we find the area of each one and then sum them together. So we already recognize we have one triangle here, right? This is a triangle right here, right here. And of course, we'll need to find the area of that triangle. And notice how on the other side you have a similar triangle. So therefore, this wedge consists of two triangles. Then we have this front face ABED right here, the front face. Then you have the bottom rectangle. Then you have the back rectangle. So we need to look at all of those areas and then we're going to sum them. So let's start with the triangle. So area of a triangle. So let's go with triangle BC. This will be half the base multiplied by its height. Half by 8 is 4 by 6 is 24. So that's 24 cm squared. So triangle BDC will have the same area as triangle. Remember the other triangle on the side right here? AEF. So this triangle will also be 24 centimeters squared. Right, let's take the front piece. That's a rectangle ABDE. So let's look at rectangle ABED or DE. ABDE. So let's find the area of that. Right, so the area of triangle, area of rectangle AB is simply length multiplied by your breadth or your width. So the longer side, we just found this to be 10. So the longer side was 15 by 10. So it will be 15 by 10. Are you seeing that? ED is 15, that's this side here. And this side up here, the BD is 10. We just worked out that. So 15 by 10 equals 150 centimeters squared. So we do the same thing. Let's look at the bottom piece. Let's see if we can make out our, right, let's see if we can make out our shapes here. Let's go back our 10 centimeter here. That's this length, 10 centimeter. Okay, so the bottom piece, which is this piece marked X at the bottom here, would be EFCD. We already have the length here, and we have this distance here as the width. So let's look at that rectangle. Rectangle EFCD. So the length here is 15, and the width is 8. So we need to work out 15 by 8. 8 fives are 40. 8 ones are 8 and 4, 120 centimeters squared. So we have just worked out the bottom piece as well. And then the last side to work out will be the back piece, ABCF. Rectangle ABCF. Area of that rectangle. Now we have to be careful here now. We got 6 as the width or the width or the breadth. This 15 centimeter distance from E to D will be the same as F to C. So this will also be 15. So the area of ABCF, rectangle ABCF, will be 15 by 6, which you know is 90 degrees. Not 90 degrees, 90 cm squared. So now that we have the area of all the different shapes that form this wedge, we will be in a position now to find the sum of those different areas of those shapes, and that will give us the surface area of the wedge. So we just need to be careful in terms of our addition. So the area of this wedge will be 24 plus 24 plus 150 plus 120 plus 90. Let's add that. +24 plus 24 plus 150 plus 120 plus 90. I have a grand total of 408 centimeters squared. Let's put that answer up here. Right, so the volume of this wedge. Now, if we look at a wedge as half of a block, right? So if we have a block here, right? If we have a block of wood like this, and we cut it straight down the center, we'll get a wedge resembling this. So what I'm proposing to find the volume of that wedge is to find the volume of this shape here, and then divide the answer by 2, because the volume of the wedge will be half the volume of this full, what you call it? They call that a cube, a cuboid. Let's see if we could find the various dimensions. So let's take the height. Let's assume it's standing this way. We got a height right here. Height will be 6. So this will be 6. The distance coming across here will be 15 by 8. Now, okay, so if we find the volume of that cuboid, then we need to just divide it by 2 to get the wedge, because the wedge is half of the entire shape, that block there. So let's do it. The volume of a cuboid is base area. We already find the base area here, which was the 15 by 8. We work it out, 15 by 8. Here it is, 15 by 8. And we multiply this base area by the height. The height is 6. So the volume of the cuboid will be the 120, which is the base area, multiplied by 6 cm, which is the height. So this will give us 720 centimeter cube. Now, volume is always expressed in terms of centimeter cube. And the volume of the wedge will be half of this, right? So half of 720 will be 360. 720 divided by 2. So the volume of the wedge is 360 cubic centimeter. And let's take the last one. Angle BDC. Well, we can go back to this triangle up here. Angle BDC, we need to just find this angle here. Angle BDC. And we know that BD is 10. We could use any of the different trigonometric rules, and let's see if we can work it out here. Let's go with this. Let's try the cosine rule this time. Right, let's go. Cosine of angle BDC is equal to adjacent, which is the 8, divided by the hypotenuse, which is the 10. So we just need to find what is the, right, they call it the arccos, the cosine inverse of that. Let's see if the calculator will be able to help us there. So let's see what trigonometry they got there. How do I do that here? And if you go second function, there you go, see? So let's put in a 0.8 first. 0.8. And let's see if we can go second function, cosine. Right, that will be 36.9 degrees. So you see that here, arccos, cosine inverse of 0.8, 36.8, 36.9 degrees. Right, let's just practice finding that angle. Tan BDC. Tan is opposite over adjacent. So that will be 6 over 8. And to find BDC, we take in the tan inverse of 6 over 8, which is 0.75. Let's practice that. See if we get the same answer, 36.9, right? So we go trigonometry, second function. Let's put in our 0.75. Let's go second function, tan. There you go, 36.9. That's what we said. And finally, let's practice it with sine. Sine BDC is opposite 6 over hypotenuse 10. So that means that BDC, we'll get the same answer, but we're just trying the only 3 different ways using our ratios, right? Sine inverse of 0.6. So let's put in our 0.6. Sine inverse, the same 36.9. Okay, so thank you so much, guys, for taking the time to look at this video. Until we meet again, may God continue to bless you, right? So bye for now.